Hello everyone, and thanks for being here for the second episode of the series, Techniques of Design and Testing of the Acoustic Guitar. So this is a round table with great guitar builders from all around the world, and we are exploring the possibilities of modern design techniques and different type of approaches to the building and the tuning of the acoustic guitar. So today we have Michael Bashkin from Colorado, United States, James Dion from Alberta, Canada, and Teunis Fick from Cape Town, South Africa. I am your host, Giuliano Nicoletti. I'm talking from Saint-Étienne, France. I am Italian. So thank you all for being here. You're very kind to participate and to share your experience and your knowledge with the community. I guess that everyone knows very well your job, your work, the instruments that you build. You all build original instruments with a high level of technical complexity, and I guess both for structural and acoustic purposes. I mean, from my point of view, it is clear that you are passionate about the technical design of the instrument and that you spend an important amount of your work to research and optimize the acoustic and the performances of your guitars. So the first question I like to ask is if there is a specific moment of your career or your growth as a guitar builder where you were really struck by this engineering passion. When did it begin feeling the needs to go further, to push further from an engineering and design point of view to improve the performance of the guitar, of the instruments that you build? I mean, a specific situation, sometimes it's a person that you can meet, a book that you can read, maybe an anecdote that you like to tell us that changed something. Or was it always like this from the beginning? Maybe also it is possible. So who wants to begin to talk about this journey into the guitar making?
Anybody feel comfortable going first? If not, I can.
Yeah, go ahead.
For me, it was when I moved to Montreal early in my career and worked at what was just formed, the Myland Guitar Cooperative. I don't really see things in a particularly scientific way, but Jeremy Clark of 52 Instruments and Michael Kennedy of Michael Kennedy Guitars, they really do. And so as I got further into things, I liked the guitars, I liked the sound of the guitars, but I wanted to know how I was getting what I was getting and to be able to develop some sort of consistency between instruments. And so that's where the sort of, desire to test and understand the mechanics of it better came for me. Yeah.
And how many people were in the cooperative, in fact?
Well, initially it was just those two and me. And now I think there's maybe 15 people there. So,
wow.
Yeah, it's a great place and lots of wonderful innovations have come out of it.
You want to talk about something about that? Some details, some techniques, some practice that you developed from that period on that you still are using today?
Yeah. Again, I don't really see things very scientifically. So I do, use a frequency generator and test all my plates, both before they're braced, once they're braced, once they're on the body. I really I can't claim that I understand that stuff, but I record it and to make sure I'm in the range that I'm comfortable with and that I understand. So that's something I picked up from Jeremy. And of course, deflection testing is something that makes more sense to me. And you can start to see the correlation between your deflection tests and your frequency tests, which is very interesting. But one thing I've come to is that at the end of it all, there's still just this feel, when you're sort of flexing and moving, that's the final little push. I think it's something that only comes with experience. I'm not sure that you can test your way to that necessarily. But I would say that all those things came from my time at that shop because there were so many guitars being built, everyone, you'd have an idea, someone builds it, we all learn from it. Version 2.0 comes along. So the structured sides that have become very popular come from originally from Sergey de Jong, and then Jeremy Clark sort of redesigned them, and I got them from him. So that's one of the things that have come from that shop.
I got them from you.
Yeah, that's right. You did. Yeah. 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 Lots of things, but I'll provide some space for others to share their thoughts here.
I guess I'll go next. I started learning guitar building at Cassini Guitars. And I was working in engineering at the time, so I started doing a weekend course there at the same time that I started working as a structural engineer. And they don't have a scientific approach at all. It's all based on feel and experience. But what they also don't build traditional guitars at all. So there isn't a mindset in their workshop where you stick to the established forms or methods or sort of the established notions of what the acoustic guitar is. So I guess that sort of put me in a position where it felt natural to question these things. And pretty soon after I started, I found Trevor Gore's books, Trevor Gore and Gerard Gillet. And that really opened my eyes, seeing a completely scientific approach, sort of engineering approach. And I think between those two things, it just put me in a position where I sort of started thinking about, I wouldn't say redesigning the guitar, but looking at every component of the guitar, and rather than looking at how it's traditionally been done, looking at the component and assessing what the purpose of it is, and then taking it from there. So something like the structured sides that I got from Dion, it's just, to my mind, a very sensible way to go about it. And I've taken it to what to me is the next step is adding struts from the waist to the head block. And eventually, when I get around to it, I feel like there's a progression of that design where the lower bout, a continuous piece, goes up into the head block, so that your structured side structure and the struts to the head block is a continuous form, and then you laminate the guitar shape around that. I haven't gotten there yet though, but that's pretty much where it started for me. Is I think just being exposed to the guitar from the start in a non-traditional way, and as a result, never really. I don't think. Well, I've bought a couple traditional guitars, but it's certainly not the way I learned to do them initially. So I'd say that's how it started for me.
Great.
I can relate to that. That I didn't have a traditional education and I didn't study with anybody, so I didn't know what a guitar was supposed to be from the beginning. So there were a lot of errors to get here, but I can't say I would choose the same path necessarily, but it has led here because I didn't know what a traditional guitar was really. Yeah.
I have a different experience than both you guys. I'm more familiar with traditional guitars, especially when I started out. And I would say overall, my influences or things that pushed me towards an engineering or more documentarian approach has been many small things. Certainly, when I come across a great guitar, one that I've played 25 years ago, and I still remember, and is among, say, the top 10 guitars I've ever played. You know, I think about what made that guitar so great, um, you know, and the fact that most of these guitars that have really stuck out to me actually have been older, traditionally designed guitars, and uh, didn't really take. I'm assuming in the 30s and 40s, you know, Martin and Gibson were not measuring frequency response curves and
Mhm.
things like that. So I've kind of come at it from both sides. I do when I got into guitar building, I had a background where I'd been working in science and used to actually designing studies and running experiments. And I was really skeptical about kind of an engineering or a scientific approach to guitars, to be perfectly honest with you, because I felt like there were some things working against a scientific or engineering approach in that the sample sizes were very small. It was hard to get an idea of things like variation and standard deviations. And just because you built one great guitar or you played a great guitar um, in a scientific sense, it's a sample size of one and doesn't really tell you actually all that much in terms of predictability. So for many years, I leaned on more of a instinctive, artistic approach, you could call it. You know, this feels right kind of thing, and a lot of bouncing back and forth between traditional designs, more contemporary designs, and then I'd say probably about the last 4 years, um, I've don't think about it as a more necessarily or sort of a light science, and um, I try and see it more as a being able to really document a guitar and provide a roadmap and a database which to draw from, you know, that can give you some predictability moving forward, you know, with your materials. And the other thing I mentioned, besides the small sample size that we all deal with, in terms of it being a negative for predictability, is also our materials are always changing. And if you told that to a chemist that you know they had to produce some kind of repeatability in a product or formula, but the atomic weights of their elements were always changing, and then you know they would quit. It drive them crazy. So as guitar builders, because often we're dealing with variation in the underlying materials, you know, that's another complexity that we have to account for. Um, I don't believe that it's a lost cause. I just believe that these things should be recognized up front for what they are, and realize that, you know, when we take an engineering or scientific approach to guitar building, that there should be some caveats along with those statements.
Yeah, I like the idea, as you mentioned, of having kind of a roadmap, because that's very much how I see my, just stack of notes, which are more organized all the time. But um, again, I don't really see things very scientifically. I have no education after high school, formal education. But especially early on, before I had the experience to sort of feel my way through it, I felt like I needed a benchmark to look at. And so I started recording whatever I could get. And those numbers could be whatever, and they mean nothing to anybody else outside of my shop. But they do give me that sort of roadmap to say, this seems to work here and that seems to work there. And I can look back and have something to direct myself. But I agree that it's next to impossible to fully quantify what makes an acoustic guitar work well.
Yeah, I've often felt like ultimately what we're trying to measure uh, is something immeasurable. We're trying to measure, you know, happiness or satisfaction on down to an individual level, and you know, you can do that qualitatively, but as you say, it's very difficult to do in a quantitative manner.
Yeah, that's right.
But then, as I'm way less experienced than either of you. I do wonder that, Michael, if you had discovered some of these methods earlier on in your career, do you feel like that would have accelerated building the intuition and the feel, having some data to correlate with what you're seeing? Do you feel like you would have built confidence in your intuition faster than by relying purely on the experience?
Yes, that, absolutely.
Yeah,
You know, there were many years where I just, you know, trying this, trying that, and it would have been great if I could have had more documentation of those things. So it's, yeah, I think I would have been all over that.
Yeah,
Yeah, go ahead.
go ahead, please.
No, it's something I think about often because I'm probably the slowest builder. And I often wonder if it's more effective to just bang them out and get through a big number of guitars, or if it's more worth it to slow down at every step and really measure things and document things, and you know, which one of those two approaches leads you to honing your craft faster and reaching a point where you're confident in the guitars you're producing. I'm not sure what the answer is there.
Yeah, I don't think there's there's a right or wrong answer about that, but my opinion on that would be that I would put more guitars under my belt if I wanted to. For me, I would feel that that's more important, that I would learn more as opposed to building fewer guitars, but documenting each one more carefully because, you know, I've seen the variation. And unless you get the numbers, it's harder for you to capture and recognize the variation that may be going on.
Yeah, maybe as the person who is between the two of you in experience, I too am an extremely slow builder, and I can relate to what you're saying. But it's almost like just trying to overcome your own little neuroses. I want to know that I'm doing a good job, and so I will get so wrapped up in just needing confirmation that I'm doing a good job because we're working in isolation and by ourselves. And if I started over again, I would build more guitars, even some bad ones, and get those out of the way. I can't do that now because my customers would be pretty pissed if I sent them a bad guitar. But I do wish I would have built just a whole bunch of guitars, because now that I've built a good number of them, there's a feel to it that I didn't even know you could have. You know, there's just this feel to the whole thing. And I still record and document, but I worry much less about those numbers. They all tend to fall in the range, but they're almost just for records now. I don't do much with those numbers. I don't manipulate much based on those numbers anymore. So yeah, I would just build some more guitars if I was starting over again.
Yeah, I get that. It is sure that the technical approach cannot be just used as a single reference to be sure that everything is going fine, and that the instruments eventually will satisfy the customer. It is clear that there is a moment during the analysis where we need to translate the data into the experience, and this gets, of course, a lot of time. Data, of course, and then also the means to understand the data, because collecting data without being able to use it, it's not meaningful, of course. But if you want, but if you stop a moment and you think about those early builds and what you're doing right now, what do you think that is that has improved thanks to the changement in the approach and the new techniques that you are adopting in terms of stability, maybe performances of the instruments? Dion?
Yeah, to me, the structural stability and the sound that I'm after are connected. So certainly the techniques, the structured sides being one, the fully bolted neck, the big carbon fiber rods in the neck. All these things lead to certainly a guitar that is more stable over time.
Do you use also a carbon fiber plate on
Bridge plate, yeah.
yeah?
Yeah, and then my backs are like a double back, or well, they're actually a quadruple back. They're no max chord, but all those structural things have led to, for what I'm after, guitars that sound better and project better, because I'm able to lighten up the structure in areas, because they're not carrying as much of the load. I can ask other parts of the instrument to carry certain parts of the load and not just the soundboard, allowing me to loosen that up. So they're connected, but certainly my guitars have gotten more volume, more clarity, more evenness throughout. And it doesn't seem to matter. Each one gets better, even though on paper they look the same. So, yeah.
I guess mine will be a quick answer. I'm still finding my form. I feel like I've had this concept of what I want my guitars to be in terms of all the different components, and I've just gradually introduced these parts over time. I feel like if I try to incorporate them all at the same time, that first guitar would take like 2 years to build, because I'd have to figure every little thing out and make all the molds and jigs and templates and stuff. So every round of guitars so far, I've made pretty significant changes to various parts of the guitar. Starting to get pretty close to what I envisioned when I first designed the guitar. But I think basically the goal I have with the concept is similar to what Dion just said, is to I guess the core of the approach is to eliminate the structural demands from the top entirely, with the exception of the bridge loads. And I think that is entirely possible to eliminate the effects of the neck on the top through strutting from the head block to the waist. And then incorporating the upper part of the back in that system. So basically killing the upper part of the back, only keeping the lower part active. And I can't really tell you how well it's going to work, but it seems to make sense to me. And I think ultimately following that approach is going to allow me to make the tops as light as they can practically be without making them structurally unstable. Yeah, I think that just even if we don't have the samples and the data to show that it works, I think just from a conceptual level, it just makes sense that wherever you need to brace the top plate to withstand structural loads, to the extent that you're then killing the capacity of the top in that area to produce sound, it just makes sense that that's going to limit how well that top can produce sound. So that's sort of my approach, and I've definitely noticed a big improvement in the sound of my guitars since I started moving that direction. Well, since the system has started coming together a bit more, and I can really lighten the tops now, and yeah, just basically lowering their mass, I think is sort of the key goal for me. And so far it seems to be heading the right direction, but I'm sure other people have gone down the same road I have and reached a point where they realize it's not the way to go. And maybe Michael has had that experience at some point, but up to this point, it seems to be heading the way I wanted to. So I'll just keep going.
Great.
Yeah, for me, probably the biggest change is in measuring materials. So all of the soundboards, the bracewood, I go through a series of measurements, physical measurements, and only now certain materials, that fall within a range, make it to my guitars. And I feel like using that approach has led to a lot more consistency and predictability in the sound. So that's probably so far has been the biggest use of a more engineering approach on my guitars.
If I can quickly, I was just thinking about I think what we're often talking about when we're testing is making something that it works efficiently. And so there's a sound that comes from a very efficient guitar, but it's not sort of, as Michael was saying earlier, like it's pretty subjective later on. It is an efficient guitar better sounding than a guitar that has some inefficiencies? And I don't think so. It sounds more like an efficient guitar, which might be someone's flavor. I have some desire to build more traditional guitars now in the exact same models, while continuing to build the guitar I build, both to see the difference in sound, but also because I think they both are just kind of different instruments in some ways. But because we build so few instruments, I think our customers are coming to us for our guitars. And so whether you build slow or fast or modern or traditional, you're developing your own little flavor palette, and people are coming for that. And all of your worries and neuroses and all that stuff that's in it just is creating your guitar that people are going to want. It's not better or worse, I don't think. We're just making our own little things.
Yeah, I would add
Yeah.
something that I think you said earlier, Dion, which is I totally appreciate and agree with everything you just said, but there's also a great learning opportunity to move away from your model, or as you say, like, actually build a bad guitar, because in a way, like if you only build, say, good guitars and you measure everything, there's going to be very little spread in the data, and it becomes more meaningful and interpretive if you have an outlier and can say, oh, okay, well, I don't like this guitar. It's different from this other group of good guitars in these key ways. So these things should be important. So I think, it, when possible, if one has the financial and the time resources to, try a different approach on a guitar once in a while, it can be really useful to you.
Yeah, I agree. I'd like to do more of that.
Just as a quick example, I think it was about maybe 2 years ago, I had, very rare for me, but I think I had like 6 or 7 of my guitars in the shop. Somewhere 1 or 2 were back in for refrets and a setup, and I had just finished a bunch of guitars, and then I borrowed some guitars locally, and I went through all the measurements on all the guitars same day. I made recordings of all the guitars, and then I also at home I have a cheap Seagull guitar that I bought for my kids to play when they were growing up, and you know it was maybe a $250 guitar, and I did the same measurements on that Seagull guitar as
Just
well. And it was only when I threw the Seagull guitar into the mix that all the other guitars made more sense. So,
is there something specific you could speak to in terms of the differences that you noticed? I'm curious
yeah,
about that.
for sure on the Seagull guitar, which was still, a musically useful instrument. It has its own charm, uh, and you could certainly, play music on it and be happy. But if you would look at the frequency response curves, everything was shifted to the right. So everything was, all the modes were higher pitched, stiffer, overbuilt. So, yeah.
Interesting.
I guess also that, Michael, your little Seagull guitar has a perfect setup, right? Because sometimes problem of the cheap instruments, it's really a good setup to make it playable.
Hmm.
Anyway, we can now a different question, something that is for you defining the technical design of your instruments, something that you have been working on in the latest years, and that makes you proud, and that you think that it's also defining the image and what your customer expects when they comes to you looking for your instruments. And maybe something that it's still work in progress, it's not satisfying, that you would like to improve, that you are working on maybe, and you project in the future. James, you want to?
Yeah,
Oh,
I've always got something to say, so I'm just always holding back. The everybody knows it about me who knows me. Yeah, the thing I've been working on lately, well, first off, I've been working on not trying to work on new things all the time. I don't really make New Year's resolutions, but 2 years in a row, I told myself to just build the guitar you build and catch up and stop changing things. But the thing I really like that I'm working on right now is I guess I'm calling it the U brace. It still very much functions like an X brace guitar. The lower bout is essentially an X, but it's like the lower legs of the X tuck into a big solid U-shaped brace that's laminated that sort of goes around the sound hole and up to the head block. And what I was trying to accomplish, and I was lucky enough to build that and one of my X brace guitars alongside it, both in the same woods for different customers a couple of years back. So I got to have kind of an A/B as close as you can anyways. And it was quite significant, the increase in everything, volume and complexity of sound. What I was trying to do though was, at least in my main model, my model number 4, where the X comes into the waist of course being already the stiffest point because of the span. It was sort of, the X tucks pretty much right into the waist, making not only that area acoustically insignificant, but the couple of square inches below that all becomes very stiff as well because of the rigidity of the X intersecting with the sides there. And so the U brace, as it sounds, just goes around the sound hole and up to the head block. And then the bottom X, which is more of a V, I guess, or an A, tucks into that. It leaves that space up to the transverse brace and where the upper leg of the X would be open. And now that doesn't meaningfully move air, but it frees up the space just below that, which would be normally below the upper legs of the X, to do more moving of air. And so that's something I've been working on, and I'm always finessing that right now.
Yeah, I really like that design. It's very cool.
Thanks.
Michael always seems to wait to be the
No.
last one.
Yeah, sorry. I was saying that the U around the hole, it reminds also a little bit of a Tornavot's design. It
Yeah,
changes,
that's right. And
it
I actually
changes a
have
little bit the tuning of the air volume, right?
yeah, I don't have a good understanding of the Tornavos. I had made a guitar with the Tornavos maybe 8 years ago. I went back to the old shop in Montreal and built one with Jeremy. But that wasn't what I was considering, but it certainly has that effect. I'm just not sure what that effect is. Yeah.
Yeah, I also recently started doing a new top bracing system. Before this, I was doing a fairly traditional X brace, although with a sort of a little lattice where the tone bars generally go in the lower quadrant. Similar to what Dion just said, where the upper legs of the X get quite close to the waist, sort of locking that whole area up quite a bit. And also with that design, there seems to be a lot of cross-grain stiffness with especially when you've got the X and the lattice in the lower quadrant, but even the tone bars, like the Martin standard shape. All of the angles of all the braces are quite flat, like they cut across the grain quite significantly. And I was comparing this with Trevigo's Falkate system, which a lot of people are using now, and it seems to give a lot better higher order mode mobility, like more overtone content, I suppose you'd say. And when you look at that system, there's almost nothing going across grain. The Falkate braces are pretty parallel to the long grain axis. They obviously curve and cut through a little bit. But then besides the top transverse brace, there really isn't much tying the soundboard together across the grain. So that sort of suggested to me that well, it made me curious to see what would happen if I did a system that had a lot less cross-grain stiffness. So I'm doing a sort of it looks like a double X, but it's very tight. I call it a sparse lattice. It's basically a 4-member lattice with I'm not sure what the angle on it is, but it's significantly tighter than an X brace. So it's got a lot more stiffness along the grain, significantly less stiffness across the grain. And I capped that with carbon fiber strands. And I mean, it's sounding better than my X-Brace guitars were sounding. Wasn't necessarily building particularly good X-Brace guitars, but this certainly has been an improvement. Yeah, I think the main sort of idea around it as well is to just spread the stresses from the bridge and the bridge plate as evenly as possible over the top. I think that's sort of my overarching philosophy on it. And I think there's a lot of ways to do that. But yeah, this is the one I landed on. It seems to be working pretty well. So I think that's something I'm somewhat excited about, if I'm excited about anything.
Giuliano, I have to admit, I kind of forgot what the original question was.
Yeah.
I apologize.
No, it was something that you are that you think that is defining your instruments from technical and performances point of view, and that you are proud of, and something that you are instead working to improve, to work on in the future?
Uh, yeah, well, that's a big question. I I'd probably say something that was kind of bugged me for a while um, was the use of kerfing in guitars. And so I moved to using solid linings. And not only do I think to me, they make sense structurally as well as acoustically. I think they have a function. But visually, I also really like them. And it took a while because of the arch and the taper of the back to sort of develop a system to produce the solid linings that install really well and work well in my guitars. So that's something that uh, I'm happy with developing that process. Uh, as far as other areas that I want to pursue, it's kind of everything. I don't think that um, yeah, I feel like there's no area of the guitar that I wouldn't want on my guitars that I wouldn't want to try and improve or tweak in some way. Um, so I'm not sure that makes sense or answers your question, but that came to mind. Those are the things that came to mind.
I feel like that the further I get into this world, I think my first guitar was built 20 years ago this coming December, and I enjoy the craft more than ever, but I also feel both more certain and less certain about what I'm doing with every guitar. There's just more questions all the time. And I think that's seems to be common amongst my friends who are builders as well. The answer just brings more questions always.
And by the way, there is a great video, Michael, the one that you produced with Stu Mac of you building a guitar that has already more than 1 million views on YouTube. It's incredible. Compliments.
About
And
1,000 of those
thank
in
you.
mine, I think. So 1,000
Well,
views in mine.
we
yeah.
can see there the way you build your laminated curving. It's great. Also that
Ah,
that you share with anyone your process.
well,
It's
thank you.
great.
Yeah, appreciate that.
I really like the bit of humor in the end where you drop the guitar. If I can for a quick second, there's a stomach bug that ripped through my house a few weeks ago. So my 4-year-old and I were laying on the couch between being sick, and we were watching Michael Greenfield's video on YouTube, and then the algorithm pulled up yours, and I was telling him, well, that's my friend Michael Greenfield, and then your video came on, and he's like, is his name Michael too? I was like, it is. And I know him as well. But he really loved your video. He said, D, this one's actually pretty interesting.
Wow. All right. Well, I'm glad it appeals to the young and the old. So,
Yeah.
but that whole thing at the end we actually more just shot it as a gag. We didn't actually think it would make it into the video. The producer was like, well, I'll just show it to the higher ups at Stu Mac, but it probably, won't make it in. But they liked it. And I'm glad they included it. So.
Yeah, it's good.
Great. So are there questions? Anyone wants to ask something? Is there something on the chat?
Paul McAvoy, come on. Come on, Paul.
I mean, that was too tempting. I guess it was a really good conversation. I feel like I have some of the same sort of thoughts as Thunis and Dion about I don't know if I wasn't prepared to talk, but sort of the value of testing versus the value of, I guess you'd call it, empirical experience. And like Michael said, that the Martin companies are coming, like these guitars that we idle are coming from factories with pretty much like production mindsets, but also have a certain magic to them that's sort of inexplicable too, that seems to be inconsistent with like just banging out guitars. You know, there's something that happened along the way, and maybe that's just from like wood aging or really good design. So but for me, I guess, you know, I've made limited efforts into testing stuff, but I'm also I think my fault right now is I'm trying to improvise, make interesting designs, try different things, and I don't know how consistent that is with testing things consistently. So and then it just seems to take a lot of time for me to try to invest in testing while I'm also trying to figure out how to make a guitar, you know, which is where I'm at. I'm like into, I guess, 15 acoustics, so I'm way behind everybody else. So just making a guitar that doesn't explode is sort of stressful enough as it is currently, and so anyway, I don't know that I have a specific question, so thank you for letting me ramble. That's it.
I have a question. Tianis, you mentioned that you are aiming to build your tops thinner and thinner. Is that thickness specific to each piece of spruce or cedar, whatever you're using, determined through Gore's kind of mathematical methods? What's kind of a range when you say thinner and thinner? What's a kind of a range that you're talking about?
I guess so. Thinner is the wrong word. I'm thinking about mass, lower mass. My plates aren't actually very thin. They range from like, the thinnest I go is normally around 2.5 millimeters. But they're normally closer to 3 millimeters, especially in the middle. Normally, it's pretty standard, would be like around 2.7. But the reason it's at that value is because I test the materials, I test the plates, and use the plates that will give me that kind of thickness. It's really about the mass rather than the thickness. So the main thing I look at when I select my plates is the density. Yeah, and I try to stay away from Adirondack spruce, for example. It's generally quite dense. I think my favorite spruce is Engelmann, but no one wants to order Engelmann guitar, so I never get to use it. And yeah, I think it's really more thinking about the mass of the entire system, and so the mass of the bridge is a important part there as well. So I try to keep my bridges under 20 grams. Generally, they're 15 to 17 grams, depending on the materials I'm using. But yeah, I wouldn't say thick. I'm specifically not trying to make my tops super thin, because that's obviously just inviting issues. So it's more about testing the plates and selecting those that are low enough density so that when you thickness them to your desired stiffness, they're lightweight, and generally the lower density plates have lower stiffnesses as well. So the plates actually end up probably being thicker than some other people are doing. Yeah.
And maybe just a follow-up question on that. Really uneducated. I've tried reading Juliana. It's gone somewhat over my head. When you speak about range, like density, kind of what range of density are you looking at for a specific spruce piece of material? Kind of just to help me if I navigate like.
I will have to look this up because I don't know this off by heart. I don't know if you can still see me. I'm just going on my computer here. But maybe. Oh no, it is opening. So sorry, this is very uninteresting to actually scrolling.
While you're looking up that up, does everybody else notice that Engelmann has fallen out of favor with the consumer? Is that what you're saying? Is that
Yeah, apparently, I don't know. This happened before I started building guitars. I don't really know why it is. I'm assuming it's because it's not as pretty as the others, and I think it's generally lower cost. I don't know if it's gotten like a bit of a reputation of being a cheaper. I think Michael would know a lot more about this.
I mean, it was a real, real desirable wood in the '90s when I was coming up. I know, I think Santa Cruz was upcharging for Engelmann even. I don't know. Maybe I'm
Yeah, I think
misremembering that.
a couple things working against Engelmann is that um, it is hard to get really clean instrument grade wood, tops without any color. Um, I'd get some of my own Engelmann here, and my heart always breaks a little when I split the log open and there's a nice like streak of um, it's usually like a reddish or almost a pinkish color in the wood, and the guitar market just won't accept that. So, but I use all for my bracewood. It's almost all Engelmann for my tops, but and this is just anecdotal. I don't know this to be true, but I'm gonna say it anyway. That I did hear that for a while, Engelmann tops were going over to some of the European suppliers and then being sold back to the US as European tops. I think they're quite similar. There's an overlap in density and certain characteristics. The other thing about Engelmann is that some of it is just spectacular and a lot of it is just shit.
Uh-huh.
So there's just a tremendous amount of variation. And just because it's an Engelmann top, it can definitely be a really, really bad top. So, but um, there's also some really great Engelmann tops.
Is that sort of what happened? They had a bunch of like Engelmann factory guitars that were just really bad, and then that uh sort of got a reputation for being that way.
Yeah, I don't actually know what happened. I mean, I'm not sure why it fell out of favor.
Okay.
It could just be sort of the supply end. It was just hard to get visually clean tops.
Mm.
Um,
Does seem to
and
be visual.
yeah,
Michael, how would you, without measuring, how would you tell a shit top from a good top? What's like, what are you're looking at wood in your shop, what are you looking at?
oh, well, I, I mean, certainly just, if you can flex a piece of wood and get an idea of its longitudinal and its cross grain stiffness, and then compare that with, other tops. I So that's just picking it up and feeling it up. But there's a lot of measurements that one can do that I do, like um, density, and then run it through a little equation that takes into account the frequency uh, of the wood and basically calculates a couple parameters. And this was the initial kind of equation that uh, Simone uses for the wooden tones. He's over in Italy, and he's certainly taken it further. But I had gotten together with Chris Jenkins and another classical builder in Wyoming, Richard, and we had um, I don't know how maybe it was 100 or more tops, and we just started measuring this and comparing it to some other methods. And the whole idea was we wanted to come up with a way that you could go visit a wood dealer and say they had a stack of 100 or 1,000 tops. What's the least amount of measurements you could take to get the information that you wanted? So what are how could you process them quickly so you could buy at what I call the tail end of the distribution of what you want? So many things their properties are distributed on a bell curve. So at the height of the curve is the average where most of the things are, and say to the left side, that's the shit, meaning the shit as in like bad shit, not the good shit. And then on the right side of the curve, the other end of the distribution is those are like the best, 10% of the tops. And so we tried to develop a method to quickly assess what is the best, you know.
So what were those parameters that you found the most useful to look at?
He
Density.
doesn't want to say.
Yeah, I'm just about to tell you the wrong things and send you off the wrong track.
Yeah.
No, density, longitudinal frequency, uh, um, those are the only two measures we take, and then the rest is kind of a plug and chug into an equation, and then it just spits out a value of whether it's true or false. Does it meet the criteria or does it not meet the criteria? And I don't know the exact equation, and I don't know what I don't know exactly what Simone is doing now. I think he's kind of tweaked things and taken it further.
Are there
And
are there
none of
district
this is like set in stone. This is all, you know, meant to be refined over time. And ultimately, you know, ultimately you have to like build a guitar with it and assess the guitar and then, you know, feed it back into the equation. So
are there suppliers that are allowing you to go through their stacks like this? How did you come up with?
yeah, well, originally it started because Chris was going over to Italy and he was going to go visit Revolta, and so we just wanted
Chris Harrod?
oh, Chris Jenkins.
Oh, okay.
Yeah, so you
Yeah,
know,
because Simone is working together with Rivolta.
yeah,
They go there, they have access to their tone wood stash. They select and measure a quantity of pieces, and then their pieces they are selected. They are sold with their brands, Tone and Woods, and of
Mhm.
course, they're working together with Chris Jenkins. They know from a long time. They are friends, and of course, they benefit reciprocally of their experience.
yeah. And my experience buying top woods over the past couple decades is, you know, probably been more of a process of frustration. Said, okay, I'll spend the money, you know, I'll buy the master grade tops,
Mm.
and you know, a lot of the times I feel like I was just getting kind of what was off the top of the pile, and the master grade was more of a visual assessment, and that's not what I always wanted. So this was a way to try and yeah, get the buy in that tail end of the distribution. The good shit.
It's it strikes me that you know, we're talking about testing and all of that, and it keeps coming back to, for you, Michael, and also for you, Tunis, and I guess for myself as well, that the most important testing happens sort of before the guitar is actually being constructed. So if you're working with good materials, and then you have that feel and testing along the way, you're gonna have better results. Maybe like a chef going to the farmer's market and getting some nice produce before they start cooking. I think that's where you have things are square, things are more predictable in that form, and you can make sure you're working with the right materials. Maybe that's where the most important testing takes place.
Yeah. Sorry, I found my information. So I should put a very big caveat here that I've tested fewer plates in total that Michael's probably tested in a day. But I found for European spruce, definitely under 400 kilograms per cubic meter. The nicest ones I found were sort of 360 to 370 kilogram per cubic meter. And then a lot of it I tested was over 400. And those were all master grade. So these are all what you would buy as master grade tops, all visually graded. And so those were for European spruce. And for Engelmann, the nicest piece I've worked with was 320 kilograms per cubic meter, which is way, I don't think you are likely to find European spruce that gets that low density. But then I've also found Engelmann spruce that's got density very comparable, even higher than some European spruce. So it's really not. You do have to test the pieces, and it's great that they're selling the plates acoustically graded now, especially for people like me who have to import and don't have the luxury of being able to return wood. It sounds like in America, well, LMI I know used to do that, where you can just return the plates if you don't like them. So you could order a bunch, test them all, and send the ones back you don't like. That's never been an option for me, and I think most people aren't in America don't have that luxury. So, yeah, master grade. After testing a bunch of them, master grade is really, it's kind of an irrelevant label to put on something if you're interested in the mechanical properties of the wood. So this maybe just remind us again what they call Travolta with their sonically graded tops. I think that's a really great resource for anyone who yeah, wants to get into this kind of thing. Because also if I'm assuming they're more expensive, but if you buy a bunch of those or a few of those and then test them yourself, you've also got a good reference to work on. If you can then find wood cheaper elsewhere, if you test your density and at least your long range stiffness, which you can do through deflection testing or through tap tone testing. If you do that on the cheaper wood you buy and you compare it to the more expensive sonically graded wood, you should be able to fairly quickly filter through the wood you're buying, and yeah, have a little bit more confidence. That's something I also struggle with. I mean, I'm very much still figuring these things out. And you get the wood and you do all the tests, and then first of all, you don't know if your results are right. So you don't know if you did the test correctly. And then even if you did them correctly, you don't know if the results you're getting are good or not. Like, is this a desirable result to get, this density, this stiffness? It can all get pretty overwhelming. And unless you have like thousands of tops so that you can then get a statistical distribution and figure out that way what's good or not, which is what it sounds like what Michael did, which is definitely the best way to go about it. But if you don't have that option, then it's, I think, probably the best way to go about it at the moment is to buy some of these sonically graded woods and use them as reference, to start getting a feel for the methods of testing them. So retest the sonically graded woods yourself and see if you get the same results, if they give you specific numbers. And then also test them and then test your own wood in exactly the same way, and then compare your results and then use that as a reference to figure out if your wood is okay to use or not. Yeah.
That's super helpful.
I just want to make
Giuliano,
a little follow-up comment
okay.
on that, if I could. Just two other resources for buying sonically graded tops is also Pacific Rim Tonewoods is now doing that, and also Brian Gallup has done a tremendous amount of work in this area, and I'm not quite sure if he's selling tops. The only other comment that I feel like it's important to make is that all of these sonically graded tops are just, they're kind of for a particular type of guitar, and I don't necessarily, it's not that tops that don't meet this sonic test can't make an absolutely wonderful guitar. Say a top with, a little denser or a little stiffer might be absolutely perfect for somebody. So don't kind of keep that in mind if you're thinking about this stuff, that just because a top is not low density and stiff doesn't mean that it can't make a great guitar, or it's up to you, to the builder, through the design and the execution, to build with the materials that you have, even though they might not be perfect according to the numbers.
Okay, so if you want to build a seagull, listen to what Mike's saying right here.
Yeah.
And just to add on this, Michael, it's perfectly true. There will be very soon also Madeira's Barber coming out with sonically graded tops. We are working together on this with a system that I designed, and that will also publish the Q factor, the damping value, which is very interesting. And Paul, in fact, what I think is we might keep in mind is that what you measure is also exactly what you listen to when you make your tapped tone sample. The fact is that the fact is that measuring is giving you more repeatability, is implying that you are using a method. I'm thicknessing the samples at the same thickness before measuring, because of course, if you tap a 4 mm plate and a 3 mm plate, you will have a completely different sound, and it will make different to compare different wood. And when you are testing the wood, you are not sure about the dimension. So there are a lot of parameters that might give a false impression when you are just tapping the wood. But if you prepare the samples before tapping them, just by tapping and flexing, you can get a very good idea of their performances. The damping, the Q factor, which is giving you the decay of the sound wood, and which is giving you indication of how the wood will be ringing after receiving energy. It's really something very clear, very evident. And there are also with the Q factor, there are very big differences, especially you can find, Michael, as you said, sometimes bad shit, that it's really bad. And with that bad shit, it's going to be very difficult to make any type of good sounding guitars. But then, of course, when you measure and when you have data, you can select, because maybe a medium average density can be good for that type of guitar, or for, I don't know, a live guitar that has to be used mainly preamplified. You are looking for a slightly higher density. Why not? It might be less a microphone and more of a musical instrument on a stage. So, of course, you always have to consider the use that you have to do.
Giuliano, can I interrupt with there was a bunch of questions in the chat that
Let's go.
I missed. Can I bust in with a chat question really quick? Ryan Elowat asks, in terms of taking stress off the top, what are your thoughts of the consequences or results of decoupling too much the neck from the body, and how those two resonant parts, body and neck, play with one another, cantilevered neck joints, etc.? Does that seem like a good question for this group?
Yeah, can I in my opinion, the neck doesn't create sound. It can sap potential sound producing energy out of the system, or it can allow it to enter the system. But I don't think, it's the way I see it, anything that is vibrating and dissipating into heat rather than moving air is energy that could have been redirected to help produce sound. And once I have that air column moving, that's the biller's job to direct that, and that's where you get your tone from. But coupled or decoupled, as long as it's not wasting your potential energy, I think that's what matters.
Yeah. I think in this case there is a right answer, if I can be so bold. Yeah, the neck isn't producing, it's not radiating sound. So and it's something you see a lot when people are talking about their neck joints. Dovetails are the best because they have the best energy transfer between the neck and the body, and I'm not ever entirely sure what's meant by that. I think to my mind, the only thing of significance to think about at the neck joint is whether or not the neck itself is stable. So whether or not over time you're going to need a neck reset. And if the neck is flexible enough, I don't think that issue would really be in the joint. I think if the joint was so flexible, then you'd probably have failure almost immediately. But if the neck shaft and the headstock is flexible enough that it's vibrating so much that it's using up the energy from the strings, because the energy from the strings is entering the guitar body through the saddle, through the nut, and I suppose through the tuning pegs. So if that energy, if that the motion of the strings, the vibration of the strings has the capacity to make the neck flutter about essentially, then that's energy that's, like Dion said, that's going into the neck, not producing any sound. And that energy could have gone through the saddle end into the top. So to my mind, decoupling the neck structurally, as long as it's stable, I feel is the more desirable approach, simply because you are then less likely to be transferring those neck loads onto the top, where you're going to have to significantly brace the upper part of the top to resist that deformation from the neck, which then means the whole top is going to be more heavily braced. And again, this is all purely if you're pursuing the kind of sound that you get from an efficient system, which isn't necessarily the best sound or the sound everyone is going for. Yeah, but Michael has way more experience on this, and maybe I'm wrong.
No, I agree. I would only add to the discussion by saying that I don't remember what issue of the Guild of American Luthiery it was, but I believe it had a picture of a guitar built by Rick Turner on the cover that he built for Henry Kaiser to take to Antarctica. And it was like the least coupled neck you could possibly imagine. It had essentially just 3 pins coming out of the body that made it into I'm not going to describe this well, but 3 cups on the neck block, or excuse me, on the neck, on the heel, and the neck was easily taken on and off the guitar. So there really was no wood to wood contact. It was just done by a couple screws, and that according to Rick, who, I mean, I didn't play the guitar myself, but Rick would certainly be believable on this subject, that it was a great sounding guitar. And I think there's enough evidence through some of the major manufacturers like Collings, Taylor, etc., that a bolted neck is certainly makes a good music, can make a good musical instrument. You don't need to have a dovetail. Many people would disagree with that, but yeah, I think the coupling the neck to the body through that it has to be tightly coupled, there's not really a strong case to be made for it. So
I've also noticed I've only made cantilever like adjustable necks so far, and there's just I feel like there's a lot of other advantages, because for me, I've not made a lot of traditional guitars, but the sort of fingerboard extension, neck joint, flattening that, getting everything to fit right is sort of taken out of that situation, because I can just route a hole in the top where the neck, like the tongue of my neck goes. So it frees me up from the sort of restraints of traditional geometry, I guess, in, I think, beneficial ways. That makes sense.
yeah, and I think there's also viable sort of top real estate in the upper bouts that can be taken advantage of and accessed if you have the fingerboard cantilevered over the top of the body. It's not how I build, but that makes sense to me, that approach.
Do you feel like the sandal would have to be moved away from the traditional spot to actually exploit that? Or do you think you can effectively use that up butt area with the sandal still being where traditionally is.
I think you could more effectively use it if you move the sound hole, but I think even if you kept the sound hole where it was, you can get some movement in that area. Chris Jenkins knows a whole lot more about this than I do. There was, I don't quite know who to credit the design to. It might be Jeffrey Elliott, but he actually had some of his fan braces on his classicals running underneath the upper transverse brace, and the idea was he was activating that part of the top, which traditionally was kind of intentionally killed off and made inert and just structural. So
It's actually a question I had for Giuliano. The sound hole, I mean, is it advantageous ideally? I mean, I know in your guitars you're not having a sound hole in the center of the guitar. Is it advantageous to have a larger vibrating area on the top necessarily? I guess in my head I'm wondering, like, can parts of the top compete with each other or cancel each other out? In my understanding of the scientific part of that is pretty minimal, but does that question make sense? Is it advantageous to have like the entire top of the guitar vibrating versus a more centralized location?
Yeah, of course, it makes sense, the question. I don't think that you will get always the same answer, though, because in fact there are different approaches, different point of view. From my point of view, you have a limited quantity of energy coming from the strings, and so even if you have a huge surface, in fact, the more you increase the surface of the active part of the soundboard, the more you increase the mass also. And so with the same energy, you will have less particle velocity, less acceleration, less displacement of that soundboard. So you won't get more sound with more soundboard directly. So it's not just opening the soundboard, giving you the chance to have more sound for the instruments. In my guitars, I moved the sound hole because, in my opinion, the place where tradition puts the sound hole, it's not the best one from a structural point of view. It's exactly where there is a static load from the strings that try to fold the guitar. My idea, it was better to move it a little bit, then also acoustical things because it's a little bit closer. So anyway, several reasons for this design choice. And personally, I think that it is better to concentrate the energy in a smaller part of the soundboard and to try to master the way it vibrates. But it's not so simple. I don't have definitive answer, sorry.
Yeah, also, this is one of the things I think I spent the most time thinking about. With the Chladni patterns, for the monopole, so the main top mode, when you look at those shapes, they sort of fall into the sound hole normally. So you've got basically your lower bout, you've got a nice ring following the perimeter of your guitar, and it sort of looks like it wants to make sort of an egg shape with the bridge being at the center of that shape. But then you've got the sound hole right there, and if you look at your tea leaves or whatever you're using to make the shape, they fall into the sound hole. So that to me suggests that that's not ideal, because that says that the top right below the sound hole is still part of the active vibrating area. The node line doesn't form below the sound hole. So now you have this free edge essentially in the middle of your vibrating plate area. So all around you've got a nice supported rim, and then at the top you have this bit that's basically fluttering about. And so to me, then it makes sense that if that hole wasn't there, Juliana, maybe you can clarify this for me. Does your monopole mode on your top, does it form like an egg shape, or does it in the upper bar also follow the perimeter shape of the guitar? Like, do you get a closed ring shape on your guitar once you've moved that? You
Yes,
do?
yes.
Yeah, so to me that's what I was sort of hoping. I haven't moved my sound holes are still in the traditional spot. I want to move them. I haven't gotten there yet. But to me, that just makes sense then, that the sound hole is introducing an inefficiency by being basically a bit of fluttering wood at the edge of this active vibrating plate. And so it's kind of similar to if you had a flexible neck fluttering and wasting energy, that part of the top right there by your sound hole, it is going to move more easily than the rest of the top. And so you are going to be dissipating energy there that could be more effective if that area was solid, and your mode could form a nice closed shape, which would just be more efficient. So to me, that does make sense. But then what you were saying as well, there is a logical limit to that, because you have a limited amount of energy. So if you made your top infinitely big, there would just be too much mass. And so on my back plates, I specifically kill my upper bout completely. So only my lower bout is active. The upper bout is purposely completely dead. And that is because the frequency range I want the back plate to be resonating in is such that I feel like the lower bout is an appropriate surface area for that. And if you start to include the upper bout, like anything above the waist, in that active area, and you're targeting the same resonant frequency that I happen to be targeting, or the range that I happen to be targeting, you need to make a greater mass resonate at the same frequency, which means you're going to have a higher stiffness, because a higher mass lowers your resonant frequency. So now if you want to raise it back up to, we want it to resonate, you have to increase your stiffness more significantly. So now you've got a system that's more stiff and more heavy, which means it's going to be less efficient than a smaller surface area that's lighter and less stiff, resonating at the same resonant frequency. So again, that then means the back is leaching less energy from the top. Yeah, so that's a long way of saying I think it makes sense to move the sound hole.
Yeah, if I can speak quickly to that. The U-brace that I'm building, that was one of the things I was trying to do, was I've always doubled up the area around the sound hole, and mostly, I mean, everything above the upper legs, the X, I've always doubled up with a cross grain spruce piece or cedar. And there's still a pad around the sound hole within the confines of that U-brace, but yeah, I'm not necessarily trying to increase the soundboard area, active area, but allow the active area to be more active by not wasting energy at the sound hole lip and not choking it off at the waist, but allowing the part below to be more significantly part of the system. And to me, the rim is the same thing, a stiff rim by whatever means. Michael, you're talking about solid liners, and there's many ways people achieve that. But similarly, you're just not increasing the sound producing area, but allowing it to work better by not having floppy edges.
Yeah.
Great. Thank you. I just wanted to have a last question for you all. Well, this is not a technical one, but this is something that for me, very interesting. In your experience, do you find that this changement that we are witnessing in terms of popularization of the dynamics and the understanding of the acoustic guitars, and also the improvements that derives from this advancement in terms of performances and sound, at least of the general overall qualities of luthiers build acoustic guitars. These changements are pushing in the same times a shift in the market in terms of awareness of the customers. Are the customers also growing with you and understanding better the behavior of the acoustic guitar and maybe what they are looking for, what they are needing for? Do you see changement from this point of view? Michael, you want?
Yeah, I think I do see a change. Certainly the the landscape of information has changed radically over the last 20 years. And I think that the way especially new guitar builders are building guitars now, the learning curve is hugely accelerated compared to where it used to be. Just in the tools and the techniques and the information available. I don't. I think that I've seen less of that from the customer perspective. I feel like the for the most part, they pick up the guitar and they play it and whatever sense of enjoyment or musicality they get out of it, that's how they make their decision. They don't ask me, what the monopole frequency is or things of that nature. But I think they're among a certain segment of customers, there is more awareness about things like efficiency and responsiveness and what guitars might be capable of versus the more traditional models. So I think that segment of the market may want a guitar for very specific things, like they do a lot of drop tuning, so maybe a multi-scale or that's the example that comes to mind.
Feel as though the market is especially in the last decade or so, much more accepting of things. I feel like when I at shows or through dealers, when I was presenting something that had deviated from what people had come to expect of the acoustic guitar, I once felt like I had to explain myself to would-be customers. And at this point, those questions don't even come anymore. I don't get emails about my neck joint or why, or is it better than a dovetail? I feel like there's more acceptance of variation of techniques. And I don't know if this is across the board, but I'm feeling like there's a general trust in the craftsperson as like they're the ones who have done the work to gather this information. And so I should trust that they know how to build the guitar and the specifics are not really up to me, beyond some, of course, obvious customizations. Sort of akin to like, I don't weigh in on my dentist's approach to fixing my teeth. They've got the education, and I personally feel like I have customers who really just trust me to build what I build these days, and not ask the whys of each deviation from tradition.
I don't think I have enough experience to really answer this question. But I will say that I think just people in general are always going to be susceptible to
Oh,
I'll finish that statement. They're always going to be susceptible to nonsense.
The internet banter, chatter.
cities.
Oh, here he is. You're back.
You were frozen.
We lost that whole thing, but
I'm sorry.
I filled in the best I could.
so
Oh,
people
yeah,
be
I could still hear you.
successful too?
Yeah, no, I think people are very susceptible to nonsense, as you say, or pretentious niceties like moon harvested spruce, as if when the wood is harvested has any effect on the mechanical properties of the wood. You know, it's a nice story, and I think you can you're always going to be able to sell instruments through nice stories, and like with any brand, any luxury item, selling the lifestyle just as much and the image just as much as the actual product. So
Yeah.
I'm not sure if the general guitar player really cares all too much about the physics of what's going on. Yeah. There's a segment though, I'm sure.
Is it too late to ask a question?
Not at all, I guess.
So my question is for Michael. In your build video, you measured the back frequency of your guitar before the top was on, but when you glue the top on, the frequency response becomes coupled and it changes, right? How do you, is there a consistent number or amount that it changes from before the top is glued on to after that you are able to kind of predict whether it's the back or the top you glue on first? And then the other part of the question, how did you attach the bridge to measure the top? Like you had like Play-Doh looking thing on it, and when you were doing the frequency response.
Yeah. Well, I don't attach it with Play-Doh. That's just a little bit of mass I add to replicate the weight of the saddle and the bridge pins and the strings. Yeah, I use double stick tape, but since then I've changed methods in that I had several guitars, I think 3 or 4 guitars in the same stage, and rather than double stick taping the bridge on, I did the measurements with the bridge off, and then I did all the same measurements with the bridge on, and it was very consistent there for the weight that I'm using, which is about I think 26 grams. There was a 19 hertz difference, so now I just don't put the bridge on the, or when I want to measure the top frequency, I don't have to add the mass of the bridge. I just change that the top frequency. I just drop it by 19 hertz, and I know that that's where I'm at. In terms of putting the back on, what I'm trying to do is just I measure the frequency of the back. I do like to glue that on first. It doesn't make perfect sense. There's some drawbacks to it, but one of the reasons I like to glue it on first is that I can really clean everything up. You know, if there's any squeeze out from the linings or the blocks or whatever, so that it's really nice and pristine inside. And I like to just take my backs down into a range that's a little bit above where I want to end up. And then once I glue the top on, I'll just reach through the sound hole, and I can easily shave the 2 lower ladder braces to get to the frequency that I would like. And I kind of sneak up on it, you know, as the guitar moves through the process, and then if need be, you know, I do an adjustment even after the guitar is finally built.
Is there a
Yeah.
predictable amount you have found that it drops when you, or changes, or
Yeah,
is it
it doesn't change much, but it's not totally predictable because it depends on what the top is doing. And I haven't really voiced the top yet.
okay?
So when I just glue it on, yeah, it doesn't change much. I mean, it might move a couple hertz, but then when I really start manipulating the top, then I find that I like to move the top and the back in concert. So, you know, I'll bring my top down close to where I want it in terms of the frequency through changing the thickness of the plate, either uniformly or on the edges. It depends on the top. And then at the same time, I will, if because my back is higher than I want, I will start taking the back down a bit, and I find that that moves the top. And so it's kind of like move a little bit of the top, move a little bit of the back, that moves the top. And so I don't, for me, they're not independent. I'm not sure if that answers your question.
No, that does. I really appreciate it. Thank you.
Sure.
I actually have a question. Can I ask a question? Juliana, in your book, you mentioned that sanding the entirety of the top plate is preferable to sanding down or thinning out the perimeter of the top plate when it comes to tuning the top. And I was curious when I read that what the reasoning behind that is.
Well, in fact, the preferable, it depends, of course, on the objective that that they are looking for. If your needs is to change the resonance frequency, as in fact the sound wave is traveling all around the soundboard, and the speed of the sound, and so the frequency related to the waves traveling within the medium, in fact, is proportional to the dimensions of the plate and the mechanical parameters and the density, stiffness, and dimensions. So instead of imagining a loudspeaker with a suspension, it makes more sense to imagine waves traveling within the plate, and the thickness of the plate is responsible for the main resonance of the monopole. So, of course, when you remove material from the sides, you are reducing thickness on the sides, you are changing the stiffness, but you are not changing the dimension on the center of the plate. And so very often the result is that reducing the mass and, of course, the stiffness is compensating. The shiftment in frequency is not very big. If you want to be more efficient in shifting the resonance frequency, and if you can do it, because of course you must not have the bridge already glued in place, it's difficult to send around the bridge, and it might be aesthetically not nice. But if you can send the whole top, it will be giving you a more frequency shiftment than just the outside. Anyway, the soundboard is not behaving like a membrane of a loudspeaker, and the waves are traveling all over the soundboard, so it's the whole thickness that it is responsible of its frequency, resonance frequency.
That makes sense. Thanks.
You're welcome.
Tunis, I had a question for you. I'm also using the structured sides, and when you're talking about putting in additional structure in the sides, I find them to be so stiff at baseline. I'm wondering what additionally you can accomplish with that.
Can you give me a second to just get a room, and then I can show you?
Sure.
Just be a second.
It's just the two of us now.
Just the two of us.
Just the two of us. Living mountains in the sky.
We have 42 other people.
Yep. It's been well attended today.
Hello. Okay, so
Wow.
So those are the structured sides that I got from Dion, and that's basically two skins with a curved core. I'm using this is Western Red Cedar in the middle. And then I've added the strut system to the up about. So like you said, the structured rims are already extremely stiff. Like even without this system, it seems like it can't move anyway. I've seen pictures of I think I've seen someone like standing on it, in terms of like from the top, and it doesn't move. So it definitely already is a very structurally sound system. But
Yes, Michael, this is a space shift. Space shift, in fact. Huh? It's not a guitar.
Okay.
It's a
Yeah, I
spaceship, yeah.
missed something.
But so the whole point of doing the structured sides, or the solid linings. I mean, the one point is to have what do they call it? Impedance mismatch between the top and the back, so that you have your waves bouncing back into the top rather than making your sides wobble. So they're doing that, but the main thing really here is to avoid the neck loads from rotating the sides, the shoulders of the guitar. So your neck is obviously pulling, the strings are pulling the neck, trying to hinge it around this point of the body joint. And the strings are also pulling the neck into the body. So it's trying to I don't have enough space here, but it's trying to squish this guy in, and it's trying to tilt your sides in. And neck resets, at least my understanding, is that the source of the neck reset isn't the top caving in, it's the shoulders deforming. And it's also not the neck deforming, it's this part of the body changing shape and tilting in that direction. So the point of these struts is to take all of the neck loads directly into the waist point. And the next, I mean, if you look at the system, what I was sort of alluding to earlier, to me, the logical conclusion of this design is to have this structured core running along the strut shape. So the struts isn't a separate thing, it doesn't get glued on. This is going to become one continuous piece, similar to, forgot what the instrument is called, but I think, like, is it an A-style mandolin? So like that have that sort of teardrop shape, they just naturally have that shape. So I will eventually, when I get to it, have a structured core layer doing this shape, and then have a skin, just the outer show layer of the guitar, laminated onto that. And then I'll probably just do some solid linings just in this upper bout area. But once you have that system, the upper bout here and the cutaway is kind of eliminated from the equation, because the neck load, which is deforming your shoulders, is just completely being carried by these struts. And I saw a question in the chat about the flying buttresses. The flying buttresses is where I originally got this idea from, but I think that this is a more robust system. Because with your flying buttresses, so flying buttresses, how can I show this on camera? Has a carbon rod going from your waist diagonally up to your head block. And of course, that carbon rod is super stiff, and that's not going to deform. But what you're essentially doing in that case is you're creating a triangle where the one leg of that triangle is your buttress, your flying buttress. The other leg of your triangle is the shoulders of your guitar. And the third leg of the triangle is the upper bout of your back, which is going from the head block to the waist. So your head block itself is pretty damn stiff. That buttress is very stiff, but then generally, if you're not doing anything to the back, you're creating a triangle with two very rigid members and one fairly flexible member, which is the upper bout of the back. And so you can't rely really on that face of the triangle for your structural integrity, and that moves your stresses the way, I mean, I think that shifts your stresses essentially to the pocket where this buttress, the carbon rod, is pocketed into the head block. Because if this the back is trying to stretch and move. This isn't moving. The carbon rod isn't changing dimension, so it's going to have to hinge around that pocket where the carbon rod is going into the headlock. And so that then becomes your weak point. Whereas with this system, you've got two members essentially. You've got on the top face, the upper arms, those are compression members, where if the neck is tilting it in this direction, we've got compression on the top, we've got tension at the back. So I've got two compression members on the top, and then these two members on the back, they get glued onto the back plate. And then I have a very staunch transverse brace on the back. So my entire back plate is very securely fixed to these lower arms. So the entire back plate becomes a very rigid tension member. I've got a pretty good compression member at the top. And then the head block itself is very rigid. So that creates a system which I'm pretty sure is capable of taking all of the neck loads, to the extent that the top doesn't have to worry about the neck loads at all. The only thing the top has to worry about is the bridge loads. So that's basically the idea behind it. And I think if you're just doing the structured side without struts, you're probably getting 80% of the benefit I'm getting by adding all of this extra shit. And every time I do it, I think it's not worth it because it's so much work. But yeah, I just think it's sort of the logical conclusion, the logical progression of the idea of using your rim to take the neck loads off of the top plate. Just sort of logically leads to adding some kind of a strut system that bypasses the top plate in having to worry about any of the neck loads.
I have to for that adjustable neck joint I'm doing, my blocks currently are just pretty massive. The neck, I have like basically a large neck block that attaches to the top, and part of that is just, you know, a very crude way of trying to displace the force of the neck. So I sort of get, yeah, that, I mean, I can see it's pretty, what you're doing is pretty difficult and elaborate, but I can see how that actually would give me room to lighten up that neck block situation.
Yeah.
So yeah.
But also,
sorry.
Yeah.
Oh, just in the terms of thinning the top with the structured sides, the first guitar I made with that was a Gypsy, like a Selmer style guitar. And I was getting used to my thickness sander, and I thickness the top to 1.5 millimeters by accident.
Wow.
And I glued the guitar together, and it's about a year old, but it sounds great. I've had no structural issues with it. It's like the best sounding guitar I've made. I'm not going to do that again, but I think a lot of, and I made a traditional style Selmer guitar with regular bent ribs, with a heavier top, and that top deflected significantly, and the structured size ones didn't deflect at all. And I think that maybe that, the ribs on the traditional guitar might have splayed out a little bit and let the top sink. Whereas with the structured side, it doesn't have that. It also has, I mean, that guitar, both those guitars have really pretty significant arching, or like the top is bent into a pretty strong arch. So a lot of weird stuff going on with that guitar, but it is interesting to me that guitar survived and is playable even after a year. It seems to be holding its own. So
yeah. Sorry, not to ramble on here, but even if you have a really big neck block, if you don't have struts, if you have a big neck block, and I think a lot of us are doing the tongue extension on our head blocks now, even if we're not doing the full bolt-on necks. But even if you're doing that's just spreading your neck loads over a larger area of the top. I mean, you're also engaging, if you've got a cutaway, you're engaging the cutaway more by having this tongue tied into it. But without the struts, you're essentially just spreading the load over a larger area of the top, which is definitely preferable to not doing that. But you're not bypassing the responsibility of the top to play a role in resisting the neck.
What I'm doing is trying to, what I got from Zach Lefebvre, I guess, is trying to get the neck block glued into the upper transverse brace, or the whatever you call that. And then I'm making that brace pretty significantly big, and then having that notched into the side. So it's not nearly as stable as what you're making, but what I'm hoping to do is take the force and push it onto that upper transverse brace.
Yeah.
Or is it the upper transverse brace? I don't know. The top brace at the neck.
Yeah.
And then having that notched into the structured sides, so that it's sort of one it's the top neck block, or what are you calling the tongue, is glued into that brace, butts up against it, and then I don't know, at a certain point I think it's probably strong enough, I think.
Yeah, for sure, definitely. And also it's less work, so it's probably better.
Yeah.
But yeah, so I don't have a transverse brace on my tops anymore. I've got, it's not an X brace, but I essentially have what would be my main X going crossing under these braces are relieved so they don't touch the top. Cool. So yeah, I don't have an upper transverse brace anymore because there's no need for it. And what you were saying with your thicker top and the traditional sides deflecting more, it's just as you were saying, like if you imagine your sides tilting out, even if your top isn't flexing here, if there's still a 90-degree there and your sides are bending, your top is going to move along with that. So yeah, having your sides as rigid as possible is definitely going to make your top deflect less. Yeah, it's just then only going to deflect in and of itself under the bridge loads, rather than it deflecting because the rest of the structure is deforming. Which then again means that you can make your top lighter, because it doesn't have to worry about the stresses from the rest of the structure influencing it.
Well, thank you for that.
Cool.
Dennis, I have a follow-up question. Obviously, for us mere mortals, it's not really possible to make that elaborate neck block that you've showed us there. Do you think a lot of the stress from the triangle that you illustrated that is now concentrated on the back when you have one flying buttress going into the head block, do you think that could be alleviated if you do two, one from either side, one going to the top of the head block and one going into the bottom?
Yeah, I mean, that's essentially what I have. I think if you do that, you don't have to make the buttresses angled. So normally the buttresses are going from the top diagonally down to the bottom part of the way. So they're like, sort of almost like they're holding the top up from caving in. But the top caving in is a secondary effect from the sides rotating. So if you have two sets of struts, which is basically what I have, if you imagine both of these with carbon rods, one going just straight in line with the top of the head block, one going straight in line with the back, when that neck is trying to move, the top is trying to push in. So your top straight buttress is going to stop that from pushing in. And the back one is trying to pull out. And your back buttress will prevent that, as long as the joints on your buttresses are sufficient to take those loads, which is again why I prefer this system, because this is all glued securely in. It's not a carbon rod going into a pocket in a block of wood, where that joint then becomes a critical thing. Like, you're then relying purely on some epoxy holding a tube in a hole, rather than relying on a large glue surface, which then that whole surface then acts in shear, which to me I think that's more structurally stable. But certainly it would be perfectly fine. The first place I saw this similar kind of thing was Mike Doolin. And he basically just had like a piece of plywood, just a flat piece of plywood, just cutting this off and cutting that off. And that works perfectly fine. And he eventually moved over to just putting a straight spruce brace from the head block straight across. So he only has this one brace, not attached to the top, like a flying straight spruce brace going from the headblock to the waist. And he says that works perfectly fine, and I'm sure it does. But you know, sometimes it's very hard to resist overdoing things.
Is that just a regular structured side kind of construction? Is the same curved core
Yeah.
that you do?
Yeah, exactly. Yeah, for the strut as well. The strut, you can see it on this side. It's also, so the top here I have, because that's relieved, I kept that in some carbon fiber. But the back, this gets sanded to the radius, and this gets glued to the back as well. So yeah, that's just the same as the structured sides.
So you see, Teunis, about communicating with your customer. It's important, right?
Yeah.
Being able to explain all of this engineering that you.
But then I don't think they care. I honestly don't think they care. Like every time I do it, I think I shouldn't be doing it because I'm 6 months behind schedule at the moment, and it just doesn't make sense to do it.
I think they do care, though. They care in that that's part of, they're coming to you for one of your guitars, and that's what you do is overdo it. And I grow onions on my bench, and that's also part of what people come to me for. And I ride my bike. I didn't mean that to be part of my brand. It's just, you know,
Yeah.
how my life looks. And I came to it naively, but certainly people are drawn to my guitars because I'm a gardener, and
Right.
guitars because you're an engineer. You know, it's like you can't separate the two, really.
Stick to your brand.
And Michael because he's just a cool dude, you know.
Yeah.
Yeah, I mean, Dennis, I would definitely agree with him that when I saw that neck block that you made the first time, I was like, immediately your breath is almost taken away by, wow, what is this guy doing?
Mm-hmm.
So that's certainly part of your value proposition as a luthier within the luxury goods market. Certainly, that's going to be something that people will come to you for.
I hope so.
Yeah.
Thanks, guys.
I have a question for Eunice. Are those mass blocks also your struts? Are they also mass blocks?
Yes, I've got a little threaded insert there.
Yeah. Do you find that with the structured sides you need to add more mass than with the guitar that's not made out of structured sides?
It depends on it depends on on how you're doing your top plate. It depends how stiff you're making it. It depends. Yeah, it depends on everything else. So far, I haven't had to use them on any of my guitars. Every time, the way I've been doing it, and I should caveat this by saying I haven't precisely hit my target frequencies on any of my builds. The target frequencies that I set out with when I start the build. When I get to the end of the guitar, I measure the monopoles, the back and top. I check which desirable frequencies they're closest to, and then I try to tune them to get as close to those frequencies as possible without falling on a scale note. And so far, every time I've been able to achieve that by most often just tuning the back plate. And because of the coupling between the top and the back, I've got carbon fiber reinforced top races, so I can't do anything directly to my top plate. But by tuning my back plate, it always starts high and I tune it down. As I'm tuning it down, I'm always pushing my top plate right into the frequency range I'm looking for. And every time I play around with the side masses, and generally I find that they haven't been necessary yet. But then if everything else was the same, but my sides were significantly lighter, then it stands to reason that I would have to add a significant amount of mass through the mass blocks to get the whole system to be what it's giving me right now, if that makes sense. So yeah.
Yeah, I've played around with them with the structured sides also. I haven't needed them, but I've played around with them because why not? And
You mean with the mass blocks?
Yeah, the mass blocks, yeah. And I've always found that I need like more than what I've heard other people using to drop the top frequency, and I associate that with the structured sides.
Yeah. I think perhaps that might be because there is already a significant amount of mass.
Yeah, as a
Um,
percentage you're adding, you need to add more to change it by as a percentage.
Yeah, exactly. I don't. I'm not sure if this is what you were sort of insinuating, but I don't think the stiffness of the sides is a contributing factor in that. I think it's purely the mass.
The mass, yeah.
Because my way of thinking about the mass of the rims, when the top's vibrating, when the top's moving in and out, the entire rest of the guitar is basically moving in counter with that, like a seesaw, because you have that hinge around the perimeter. So your top moves in, the rest of the guitar moves up. That's your back plate and your entire rim. And I suppose the weight of your neck as well is the mass of, not the weight, the mass of all of that together. The stiffness doesn't come into play there. The only place where your stiffness comes into play is basically the impedance mismatch between your top and your side, basically wasting energy in the vibrating of the other components. So I think it's like Dion says, where it's like you already have a lot of mass, so to get additional benefit from adding mass, you have to proportionally add even more mass to get the same kind of frequency shift that you would get on a light rim that you then start adding mass to.
Yeah, that makes sense.
Yeah.
My other question was, you mentioned earlier, like if you had like an infinitely large soundboard, the mass of that soundboard is so large where it's not as efficient. And so, are you saying like a smaller guitar has more potential for being an efficient guitar?
No, what I mean by that is that I feel like I'm talking way too much. You have a set amount of energy from the strings you're using. So whatever gauge of strings you're using, when they're tuned to pitch, that's a set amount of tension, a set amount of energy that they can impart. And there will be a mass or a surface area of the top that's appropriately coupled to that amount of energy. So if you've got a larger body guitar, I think it makes sense that you would need heavier gauge strings to drive that top to the same extent that a lighter gauge of strings is able to move a smaller body guitar. So I don't think a smaller body guitar has more potential. If you go too small, you also don't have enough surface area to move enough air. So it's really just a balancing between the amount of energy you have available to the surface area, which the surface area is related to the mass and the stiffness.
Okay, that makes sense.
Yeah.
Thank you.
You got it.
Wow, so a lot of questions this time.
Yes, sir. That was good. What do you think? Should we leave them want more, Giuliano, or do you want to keep going?
I think that we are more than 2 hours on. So if everything is okay with you, I would say we can say hello to our guest and finish here. What do you think?
Yeah, let's do that. Everybody, unmute and say thank you to our guests, and especially thanks for Giuliano for organizing this. This has been really awesome. Like, really enjoyed this, fellas.
Bring them back again.
Thank
you.
Thank you. That was great.
Thank you. This was
Thank you
amazing.
so
Thank
much.
you very much.
That was great.
Thank you. Yeah, this was great.
Thank you.
Thank you.
Thank you. Thank you.
Thank you, everyone.
I have no lights because they're all on my onions right now.
Yeah, so that it's
Look at this.
Yeah.
That's
7,000.
exciting.
Yeah.
Are those gonna go to maturity in your shop, or are those starts for when spring arrives and you're gonna?
Yeah, there's starts. I'll plant them out in April in I manage a charity garden. It's 2 acres or so on the university campus. They'll go there. We normally grow them in a greenhouse, but it's under renovation at the university, so my shop's become a makeshift greenhouse.
Oh, that's great.
What do you
There
think,
any
Ian?
other,
We're coming in?
starts besides onions?
Yeah, we will, but onions are just the earliest, and the rest will be grown at some professional greenhouses that donate space to us. They're just not up and running for the year yet. So. It's pretty cold here still.
I can imagine.
Like it was minus 25 last week Celsius.
Um,
And you still go with the bicycle in the shop in the morning.
Yeah, all year round. It makes you feel real, when you get to
Very,
work,
very
you feel
real. Very
happy and good and ready.
That's because you can't feel anything.
It's true.